One of my classes last week just did not load at all, and I do not know why, but it didn't. But so if you do miss one, it does happen sometime, but I'll try never to. That's the first time I can recall that happening, but it can happen. All right, 3 areas of safety. Now, doing math problems really doesn't require a lot of safe practices, does it? Okay, so what are 3 general things of safety we have to keep in mind always? Say again? Yeah, okay, he's been in the class before. Weather, fire, we'll get to the third. Let's start with weather. Hey, people in Houston and Texas, they're suffering through it now. My wife saw pictures of tornadoes there. So it can happen in the fall. Most of the time it happens in the spring, but it can happen in the fall. If we hear that alarm go off, this class doesn't meet anywhere near 11 o'clock on Wednesdays when they do the testing. So what do we do if we hear the weather alarm go off? What are the procedures? General rule. Say again? Okay. Hallways are generally okay, but you want to do another thing. Say again? Okay, absolutely. Go away from windows. So one big term to keep in mind, interior. Interior. And the other is low. Okay? Low and interior. Now, where we are right now is in this classroom here. Okay? Corner classroom here. This is second floor mapping. Okay, what we do to get to evacuate, we go out of the room here, take a left, go down this half flight of stairs here, take an immediate left there, go down one more flight, and then go interior. One of the first places you'll see as you go interior are the restrooms. And literally, they're one of the safest places to be. Here's why. The walls are close together. You said hallway. That's why hallways are better than classrooms. The walls are closer together. Come on in. Can I get your name, please? Donald. Donald. Oh, you're Donald. Okay. First page. Number 2, I think. Yeah, Donald's here. Okay. So you go down that full flight of stairs, and when you're near the restrooms there, now, granted, most of us probably not rather spend the next couple hours in the restroom, but they are a very safe place. The walls are close together, and not just that, you've got corners. The greatest strength of a building is in the corners, okay? After that, the walls, okay? So, in either of those restrooms there, pretty safe, especially the back wall, because that's up against soil, down on that first floor. Right next to that, as you go down the hallway there, is it says corridor here on the second floor. On the first floor, it's the dean's office, okay? That's the academic dean, and sometimes her associate dean is over here, and occasionally one of the other instructors from the Birmingham campus will use that office. If that office is open and they invite you in, that's a fairly safe place. Again, close walls, corners, okay? After that, those 3 places, probably the next safest is the hallway. Because again, the walls are close. What you don't have are corners. But what you do have in the hallway that you don't have anywhere else is emergency lighting. And if we indeed did have a severe weather event, such as a tornado, severe thunderstorm, it could easily knock out power. If power is knocked out, the restroom might get a little bit creepy, to stay in a dark restroom for a couple hours. Probably not. You probably want to get out in the hallway where there is emergency lighting. So anywhere along that hallway. Now, both of those walls, neither one of them have soil behind it, so they're safe, but the strongest are back here. Okay. If that hallway is really crowded and you still have some power or whatever, the classroom, now this is the second floor classroom, but right under that is room 160, which is the developmental math classroom. Now, disadvantage, big open space in the middle. Advantage, interior, and this wall back here is really safe. because that's got soil behind it. There's no structure behind it that would tend to fall. So, and the corners are better than the walls, but the walls are safe, and the corners are best. The back wall is the best one. Okay, after that, if you continue down that hallway, through the glass doors in the middle of the, about 2/3 of the way down, you're entering the library when you go through those glass doors. And immediately on your right then is a computer room, the library computer space. That room is smaller than the classroom, so the walls are closer, and you still have corners. And just next to that is another room in the library, and I don't know the official name. I call it the research room or the reference room. That's where your atlases are, globes, and that kind of stuff. Not where you check out books, but books that you can use and stuff. That one's a little bit bigger than the computer lab, but it's a fairly good space. Now, one disadvantage there, a lot of tall shelving in there. So if you did have a wall get shaky, the shelving could come down, but I don't think that's likely, especially this back wall back here. Okay? Don't go any further in the library for exactly what Jesus said. Stay away from windows. All the rest of the library rooms are exterior. You don't want to go there. Okay? So, that's what we do in case of a weather emergency. Now, a couple of other rules on that. All of you look pretty able-bodied right now, okay? But it could be that some of you could be in a basketball game and twist an ankle or wrench a knee or something like that, and could be a little bit incapacitated. If you are, I'm going to be with the last person out, the slowest person out, making sure you get downstairs to safety. The rest of you are filing out in a very orderly, safe, reasonable speed. Don't want you rushing downstairs. Don't want to write up any incident reports of you getting a broken leg or something. So keep it easy, gentle, safe. Get downstairs and wait until we all get there. Like I said, I'll be the last one. I will carry with me my roll book. Okay, I don't have your names in it yet, but I'll carry those if that's what happened today or this week. Okay, and then once we're down there, I call the roll again. Make sure we can account for everybody. That means don't say, hey, bad weather's coming, I better get home. I got to let the dog out. No, leave the dog alone. The worst place you can be in severe weather is on the road. Just about the worst place. Do not do it. Also, don't go, well, my buddy's down here and, the other end of the hall, I'm going to go visit with him or her. No, okay? Stay together, at least to begin with, till I can account for everybody. Otherwise, somebody has to come up to the place where it's dangerous and start looking for you and putting somebody else's life or health in danger. So stay together, at least until I can call roll, and then we'll see what happens. Okay? We'll stay wherever they tell us, but you can mingle around and visit and that kind of stuff, find something a little more comfortable. But stay together to begin with. Don't start distributing to those other rooms until I've got the roll call. Okay. Any questions on weather? All right. The other was fire. What if there was that's weather is an external emergency. We go down an interior. What happens if there's a internal emergency? Okay? As in, and let's start with the worst case scenario, my computer blows up, okay? And, okay, get away from that. Catches the papers on fire, okay? What do we do? Say again? Okay, certainly get out is one of the things we're going, and the vast majority of you, that's all you have to worry about. But we need to do something else. Say again? I can't hear.
Stop, drop, and roll.
If you're on fire, yes, but hopefully you're not from there. It hasn't since sparked that far, okay? So hopefully that's not an issue. But if it is, we take care of that, okay? Very good. What are some other things we have to do before we get out of the building?
Blow the fire alarm.
All right. For a fire, we need to let the rest of the building know the building's on fire. We don't just get out and say, we're safe. Who cares about you guys? We let somebody know. And the best way to do that is fire alarm. Now, where is the closest fire alarm? Anyone? Anyone tell me?
Downstairs.
Downstairs. This old part of the building here, represented by this horseshoe here. Actually, it's two old parts. The one old part starts right about here and goes this way, and then the next old part here. Both of those were built before fire alarms were required by code. Believe it or not, that was the case. So the only part of the building that has fire alarms is the newer part. The next newer part that was built was this one over here, so that's a long way from us. The last part that was built was the part in the middle. Now the reason nothing shows up here is first floor, we're second floor. So down in here, this is student suite, student services wing, I call it. There's not a wing. But that's where financial services is, the registrar's office, the admissions desk. They're all in this part. Okay? That's the part, that's the closest part where we have a fire alarm. So, I would suggest two people go, buddy system. You go out the door here, down the half flight of stairs. Don't go out of the building yet. Go down to this corridor here. Go across. Now, this is a strange corridor. You're on the second floor here. You walk through that corridor. Don't go up or down a single step, and you're suddenly on the first floor. That's because that wing is the bottom floor there. And go either right or left. You'll see a fire alarm in either place. Whichever is closest and easiest to get to. So there's the closest fire alarm. All right, that's one thing we need to do if the fire starts in this room. What's another one? I'm sorry?
Get a fire extinguisher.
Okay, fire extinguisher. Where's the closest fire extinguisher? Okay, that is much closer. 5 feet from where I'm standing, right here, there's the closest fire extinguisher. Yeah, you've always wanted to break that glass, haven't you? I mean, it's itching to. So get out there, break the glass, bring the extinguisher in. I'll deal with the fire. And if you don't want to break the glass, somebody will, or I will do it, okay? So we'll take care of that, okay? Now, okay, I'll leave that for a minute. One more thing we need to do before we leave the building. What's that? The fire alarm's going to let people know, okay? But one thing we need to do. Call, okay. I'm going to give you one number better than 911. And all of you should really put this on speed dial on your phones. It's the Lawson State Police, okay? Now this number, if you look it up in the directory and stuff, you'll get a number that's on somebody's desk. And if no one's sitting at the desk, it does no good to call that number. This is the number I was told by the police chief on this campus, or the lieutenant in charge on this campus, that this number is the one that whoever's on duty always has with them. So you should always be able to get an answer at this number, and the person who can respond best. And here it is. 426, I'm going to get, so be sure this is recording here. 426-3654. 426-3654. Now, if you don't have that on speed dial on your cell phone, then 911's next best. Because campus police can get immediately into the 911 people, and they can start the process here. They get a little embarrassed if the fire department shows up and they don't know why they're here. So please, let's contact our, and the alarm will do that as well, but they don't know where. So if you call them, tell them 355, blah, 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 yeah, or whatever room you happen to be in, have that number available. All right, now we've gotten the fire extinguisher putting out the fire, we've pulled the alarm, and we've contacted emergency personnel. Now we proceed to get, well, y'all, the rest of you can start getting out of the building right away. How do we get out? Just like before, you go low, but this time you go out. Now this isn't just fire. Chemical spill, anything like this inside the building that would produce a hazard thing, then we go out. So we go out of the door here, take a left, go down that half flight of stairs, take a left, go down one full flight, rather than go in, you go out. Now where do you go? Those of you who are close to the window here, we used to tell people to go into that grassy area there at least 75 feet away from the building. And that would be fine. Now we want everybody in the parking lot. Now, the reason they want you in the parking lot is so you can get in your car and go home? No. Okay? Please stay together as a class, as a group, because remember, we got people going out getting fire alarms, fire extinguishers, pulling fire alarms and stuff. We need to all get back together in a group. I will be the last one out of here with that slowest person after I fought the fire, whatever it takes. I'll have my roll book with me. When we get out there, I call roll. If you have wandered off or decide, hey, the building's on fire, no more classes today, I'm out of here, don't do that, because if you do, we can't account for you. Someone has to come back into a burning building looking for you, risking his or her life or health. Please, stay together. Someone will come around and say, hey, okay, we're going to relocate classes in these buildings, or hey, folks, it's all right to go home. Someone will come around and tell us, don't do it ahead of time. Don't preempt them. Let them tell us. Okay, so there is external emergency, weather, internal emergency, fire or chemical spill, something like that. One other, and we never used to even mention this. I never even thought about it.
School shooter.
Active shooter. Man, I wish we didn't have to say this, but there's been, I've only heard of one community college somewhere in some other state somewhere, Michigan, somewhere, Wisconsin, I don't remember where, who actually had an active shooter at a community college. Several universities have had it, unfortunately. Movie theaters, elementary schools, I mean, it's been often enough, though it's not very often, not very likely, but in case it is, what do we do then? Okay, lock the doors. All right. Nick did it, lock the door. No. What's your name, please?
Sheffield.
Jeffrey?
Sheffield.
Sheffield. Okay. All right, Jalen, right? All right, we just talked about safety. You can listen to the first part of it on YouTube once you get this set up. So, you need to lock this door here. Unfortunately, this door does not have a button or something you can lock it from the inside. No way to do that. I, however, do have a key for the door, but I have to go outside to lock it. So I will do that, get it locked from the outside, then I'll come back in and close the door. Okay. All right. I'll lock it from the outside. We can still get out, but he can't get in. Okay? So we got this door locked. What's the problem, though? We've got another entry to the room. Okay? Now, think. Can't do everything there because there's a study group that looks like in there. But, here's a door. Would this be good to lock? It does have a button on the side. I can press that button, and it locks here. But it doesn't lock from the inside where he could come in. So that does us absolutely no good. It locks us in the room but lets him come in. No, you don't want that. This door, there's a deadbolt in it. Okay? I don't have a key for it, so I can't lock this. But that next door, the one leading to the next classroom, does have a button like this. And it locks from the outside, but we can get out from the inside. That's the one someone goes and presses this button and closes the door. Now, if you're that far, go in and close the hall door. Okay? The door from the protection to the hallway there. Sometimes, it used to happen almost every other day or even more frequently, for some reason, security would forget to unlock that door. If that were the case, that's another locked door there. So close that door, turn off the light so he thinks that room is vacant too. But right now, security, I got on to them a little bit. So look, we got classes all 4 days of the weekend here. So they started unlocking the door. So that's sort of bad, but it's good for the people who have classes there. So we lock that door. And guess what? That door has a window he can see in. So be sure you close this door as well. We can't lock it, but have it closed so you can't see that there's anyone here. Okay? Then go on and close this door. Don't lock it, but close it. Okay? What else do we do? Then we've got the turn the lights off and get get away from sight. He can look in this window. If he sees someone, he can start shooting through the glass, shooting through the door. We don't want that to happen. So we get quiet. We get over here. Okay? Safest place to be in here. He cannot see in. Cannot see in. As far as he knows, the room's empty. So let's let him think that. He doesn't hear anything. He doesn't see anything. Passes on by. Can't get in. Goes look for somebody else. Okay? So, that's what, and we stay there. Stay quiet. Oh, wait, let me back off one thing. As I've told you before, I'm hard of hearing. If there is active shooting going on in the building, you will hear it before I will. Let me know, okay? Don't let me just think, oh, I don't want to miss anything in class. Come in and let me know. And then, of course, I'd say somebody call campus police. They'll probably already alert to it. But call campus police, 911. Get that done very early so we don't do it anymore. And turn the phones to silent. Because you don't want them walking by and hearing a phone ring in here. There are some people in that room. So turn your phones to silent. Get back here. And we stay very quiet and do a lot of praying. Okay. And in time, someone will come and let us know. And we don't open that door until we're certain it's someone that's official. Okay? Sorry we have to even mention this. Okay? But unfortunately, in today's environment, we have to. Any questions on any aspect of safety? All right. Sorry about all that. All right. Finally, we get to math. Any questions about anything before we get going? By the way, those who came, did you have a question? Oh. What's that? Okay. By the way, for those who came in late, I was not able to get the stuff loaded on Blackboard, and other students have told me too, couldn't get Blackboard to work last night. So Friday was almost a wasted day. I was doing things just constantly on Friday. All right. Now, I think I told you before, Chapter 1. Chapter 2 was stuff you should have had in 090, 098, high school, somewhere. If you scored or for any reason are here, you should have already had that stuff before. Has anyone reviewed that and run into anything you say, you know, we may have covered this, I sure don't remember it, this is all news to me, or it's so fuzzy I don't remember. Anyone have any questions on chapters 1 or 2? Or sections 3, 1, 2, or 3? We're not going back over those. Well, I'll go over what we need to when we get there. We're starting in 3.4, factoring. Now, you had this in high school. You had this in 098. Okay? But we're going to take it probably a little bit further, maybe do a little bit more with it than we had before. And what do we factor? We factor things called polynomials. What in the world does that word mean? Polynomials. What does the prefix poly mean? Multi, many, okay? Exactly. Now, this is a little bit weirder. Nomials, I think, comes from the French, or probably before that, Latin or somewhere, meaning names. So this is many names. Well, names makes no sense in math. What we mean by it is many terms. Now, what in the world is a term? A term is any mathematical expression that's made up of numbers and or variables that are either multiplied or divided among themselves. Okay? As long as what you're dividing is a number, not the variable. Okay? The numbers can be divided, the variable cannot be. Okay? So in other words, it is something like 4x cubed. That would be a term. Negative 3/5 y squared. That would be a term. Minus pi. That would be a term. Just a number. It doesn't even have to have a variable in it. Okay? Now that's a term. Okay? What do we mean? And how are terms distinguished within an expression from other terms? If they're things that are multiplied or divided, what would separate them from other terms? plus or minus signs, okay? A term will not contain a plus or minus sign except maybe at the beginning, but an expression could have many terms separated by plus or minus signs, okay? Now, let's go back to that many or multi. In math, that can be as few as one. A single term is a polynomial. It's called a monomial. One term, one name, okay? So that's basically what polynomials are. So how in the world do we go about, and that's what 3-1, 3-2, and 3-3. I basically summarized that in what we just said now. So let's get to 3-4, which is factoring, and we're going to start with the very simplest kind of factoring, and hopefully this is old hat to you. So this first bit should be very easy, a review, good scores coming out of it. Greatest common factor and common binomial factors. What would binomial mean? Two terms, okay? Bicycle, two wheels. Binomial, two terms. All right, what our objectives are in this set of 3.4, classified numbers, we're going to start with numbers, as prime or composite. Okay? Why are we going back to numbers? I thought we were in algebra. Well, algebra is made up of numbers. Number 2, factor composite numbers, okay, into a product of prime numbers. Ooh, we did that way a long time ago. But then we'll be understanding the rules about completely factored form, not just of numbers, but of polynomials. And we'll learn to factor out the highest common monomial factor. And then, of course, we'll move from there to factor out the common binomial factor. Okay? And we'll use that term a lot when we factor by grouping. Okay? We'll talk about that one. And then we'll use factoring to solve equations and solve some good old word problems. Yes, everybody's favorite that involve factoring. Okay. Now, pretty simple stuff. 2 and 3 are said to be factors of 6. What's another term that you could use rather than factors? Say again? Okay. Very good. Now, that's, the verb factor is basically like the verb to divide. Exactly. So these factors would be the things that are multiplied together, the multipliers that make up 6, or 2 and 3. Now, there are 2 more. Can anyone think of them? 1 and 6. Now, all you've given me so far have been natural numbers. Another name for that is, counting numbers, okay? 1, 6, 2, and 3. There are other factors of 6, but let's not even go there. Like 12 halves and 2, okay? Oh, no, I'm sorry. 6 halves and 2, or 1/3 and 2, okay? Yeah, you can do that. Let's not go to fractions. Let's keep the factors to be whole numbers or counting numbers, okay? And most of the time, even though 1 is a factor, we're not going to count 1 because 1's a factor of everything. But that's if you have just a pure number, 6. Likewise, in a product, okay, so if factoring is like dividing, when you combine factors together, you're multiplying. So here's 7ab. That's an expression. That could be a monomial. That could be a term. 7ab. What are the factors of that? 7, a, and b are all factors of that. And actually, there's a couple of other factors. 7a is a factor, and 7b is a factor, and ab is a factor. But when you completely factor it, 7a and b are the factors of that product. Okay? Now, if a positive integer greater than 1, that's why, remember, we don't count 1, has no factors that are positive integers other than itself in 1, it's said to be a prime number. Does anyone see a prime number on the board right now? Say again? 7 is certainly a prime number. Another? Say again? Okay, 13 is a prime number. It's not on the board right now.
2 and 3.
Say again?
2 and 3.
2 and 3. Those are both prime numbers too. Is 1 a prime? Nope. Any positive number greater than 1. Okay? So we don't count 1 as a prime number. Okay? Okay? But any number greater than 1 that has no factors other than itself and 1, that's called a prime number. And you listed several of them. Okay? Let's go through and do the between 1 and 20. What are the prime numbers? You already named a couple of them. 2, 3, 5, 7, 11, 13, 17, 19. Very good. Y'all are good. Okay. Those are prime numbers. Okay. What wasn't 9? 3 times 3. Okay. Does the prime numbers less than 20? You just did them. 2, 3, 5, 7, 11, 13, 17, and 19. Now, a positive integer, y'all know what integers are, right? Okay, good. Okay, positive integer greater than 1 that is not a prime number is then called a composite number. Anyone think of one we had on the last slide? 6 was. 4. Let's name all of them between 1 and 20. 9, 4, 8, 6, 12, 14, 15, 16, 18, 20. Excellent. Okay. Those are the composite numbers. And here they are. Y'all are reading through my shirt. Okay, no. 4, 6, 8, 9, 10, 12, 14, 15, 16, and 18. Okay. Every composite number is the product of prime numbers. For instance, 4 is 2 times 2. Now, that's one way we can write it. Another way is 2 squared, if you want to be really lazy and not have to write a time sign. How about this one, 63? Is that prime or not? Not, okay? How would you determine the prime factors for 63? Multiplication. And what two numbers would multiply to be 63? 9 and 7. Is 9 prime? No, what is multiplied to? 3 times 3. 3 times 3 times 7. You're very good. Now here's another way to do it. That was what I called the Christmas tree method. The tree method. You start splitting it up and keep dividing until you get there. Another way is to pick the smallest prime number that will go into 63. What is the smallest prime number, period? One's not. 2. Will 2 go into 63? No. Go to the next smallest prime number. Will 3 go into 63? Yes, it will. 3 will go into 6 twice. 3 will go into 3 once, so it's 21. Is 21 prime? No. Okay, what's the smallest prime number will go into 21? 3. 3 times 7, both of them are prime. So 3 times 3 times 7. Okay? That's the other way. I call that the brute force method. Okay, you just go through it one at a time. That's a little more organized, perhaps. The other is usually a little quicker. Okay? Any questions on that? All right. The indicated product form that contains only prime numbers is called the prime factorization of a number. So the prime factorization of 63 is 3 times 3 times 7, or like I said, you could write that as 3 squared times 7. Either of those is fine. We also say that a number is completely factored when it's in the prime factorization form. Okay, we're dealing with numbers. You probably had this a long time ago, right? I hope this is a useful review. If not, at least a review. Let's move on. Any questions? Okay. In general, factoring is the reverse of multiplication, so therefore it's similar to division, as you already pointed out. The distributive property to find the product of a monomial and a polynomial, suddenly here we've jumped into algebra. Away from just numbers, now to expressions. Okay? Distributive property to find the product of a monomial and the polynomial. Here's the general way to do it. Okay? Now, again, this is what you had in the first 3 sections. There's an expression. That one is in These are in factored form, okay? Because those are completely factored. Well, what can you do with that? Distribute it, and that becomes 3x plus 6. Very good. So here's the product. That one multiplied becomes 10x minus 5. There's the product. And this one would become? Very good. And that would be the product. Okay? We already know how to do that. Multiplying, distributing, going that way. But you know the distributive property works this way as well. If you have a form like this, then you factor out the common factors. Divide out the things you can divide into that. And you can factor out the 3, that gives you this form. Factor out the 5, that gives you that form. Factor out the common factor of x, that gives you this form. So basically factoring is the reverse of multiplication. Okay? And we'll deal with this in many ways a little bit later. Okay? These are the pretty easy ones. We shall also use the distributive property, like I said, in the form of, this is also the distributive property. AB plus AC is equal to A times B plus C. Factoring out the common factor. To reverse the process, that's what we just were saying. Here it is, written the other way. Why they took up 2 slides to do it, but it's fine. This is exactly what we did before. To factor this, find the greatest common factor between the two, 3x and 6. Greatest common factor is 3. Factor it out by distributive property. That leaves you x plus 2. Greatest common factor here is 5. Factor out the 5. That leaves you 2x minus 1. Greatest common factor here is x. Factor that out. You get x times x squared plus 6x minus 4. Does everybody see that? Pretty simple stuff. Okay. Now, in each of those examples, a given polynomial has been factored into the product of a monomial and a polynomial. Obviously, polynomials could be factored in a variety of ways. Okay? So, let's start with this one. How would you factor that polynomial? The greatest common factor would be 3x. It appears here and appears there. And when you factor that out, what do you have? Say again? X plus 4 is what you say? Very good. 3x times x plus 4. Now, that's the best way. Okay. If you only saw the 3, didn't see the x, or didn't notice that the x was also a common factor, you could do that and factor out the 3, and you have x squared plus 4x. But then if you look closely at this, you say, wait a minute, there's another factor, so then factor out the x. Easier, quicker, more efficient to factor out the greatest common factor. But if you don't see it, factor out what you can and then look for more. Or if you saw the x first and factored that out, you see 3x plus 12. X times 3x plus 12. But then you say, wait a minute, there's a common factor there between 3 and 12. Now, of course you're going to see this, aren't you? No! Don't mess around with fractions until we have to. I know you love your fractions, okay? But let's put them off as long as we can, okay? No, we don't want to factor this way because now you've introduced it and actually made this more complicated, not simpler. The whole purpose of factoring is to get it into the simplest expressions. We are, however, primarily interested in the first of the previous factorization, that one, which we refer to as completely factored form. Now, I can hear someone say, but wait a minute, can't 3x be factored into 3 times x? Sure it can. But guess what? Once you get it to a monomial, leave it as a monomial. You don't have to break it down any further. Okay? And for binomials, if you have a binomial, is there any other factor? Get it out there with the monomial. Okay? And don't mess around doing this, making it more complicated than what you had to begin with. Okay? Any questions on that? All right, so here are the general rules for it that we just illustrated. Let's say what the rules are now. Polynomial with interval coefficients. Again, remind me what integers are?
Number.
Say again? Someone said it, but I can't hear well.
Numbers.
Numbers, okay, but 1/2's a number.
Whole numbers.
Okay, whole numbers. Okay, in other words, think of them as counting numbers. 1, 2, 3, 4, 5. How many of you count? 1/2, 1/3. No, we don't count that way. We count 1, 2, 3, 4, 5. Okay, the counting numbers or the whole numbers are the positive integers. Now, the reason it just says integral coefficient, this allows for plus or minus signs. So counting numbers are just the positive side. The integers count plus or minus counting numbers or whole numbers. Okay? A polynomial with integral coefficient is a completely factored form if it meets these two criteria. It is expressed as a product of polynomials. Remember, a polynomial may be a monomial with integral coefficients, no fractions at 1/2. Don't want to do that. So that's the first one. And no polynomial other than the monomial, that can be factored further, but other than the monomial, within the factored form can be further factored into polynomials with integral coefficients. If they can, keep factoring, okay? But so you want no fractional coefficients and you want no polynomials left over can be factored further. Keep factoring. And now it says, do you see why the first of the above factored forms, that 3x times x plus 4, that's said to be a completely factored form. No fractional coefficients, good, and no the final product expressions, except for the monomial. Final polynomial form cannot be factored any further. So that's what we do. In each of the other three forms, the polynomial inside the parentheses could be factored further. So that's why we don't factor out fractions, and that fraction breaks both rules. Okay, conditions using only integral coefficients is violated. Okay, does that make sense? A lot of big weasel words, but it's a pretty simple concept. So let's do some of these. Okay, and unfortunately they've done it for us. So, can that be factored? What would be the greatest common factor? 4m cubed, 4m cubed. So let's factor that out. Whoa! Did they get this right? No, they only factor out 4m squared, leaving them m plus 2m squared n. What's wrong with that? Is that completely factored? No, why not? You left an m in here, you should have pulled out there. Why they show you these things that are incorrect, I don't know, but that's what they're getting at. Okay, how about this one? Don't read my hand. Okay. 8p cubed. Factor that out. What would be left? Four p q cubed plus 1. Very good. Don't forget that plus 1. Is that completely factored? Yes. Very good. How about this one? Factor out a what? 8, you said? 4. Factor out a 4. X squared. Y squared. There we go. And what's left? How about a 2? 2 cubed plus x. You got it. Oh, what did they do here? They messed it up. They factored out 8, and what did that leave them with? A fractional or a decimal form. Wrong answer. The way y'all said it was right. Not 8, but 4. Greatest common factor was 4. Yeah, that's what I said. This is saying if it is not completely factored, state which rule has been violated, you have a fractional coefficient. So why even show you something that's wrong? I don't believe in it. Okay, how about this one? Say again? 10 AB. Okay? Did they do it right? No, they didn't get greatest common factor. They got a common factor, but it wasn't the greatest common factor. Why? Look at what's left over. 5b squared plus 10a cubed, guess what? Has a common factor. Include that in here. 10ab, and then what would be left? If you did 10ab, b squared plus 2a3. Okay, very good. Okay. They wanted you to do it a different way, but I think it's better to do it the right way rather than say, oh, no, that's not right, you know. All right. Any questions on that? All right. And the first one, no, it's not in completely factored form. The polynomial inside the parentheses has to be factored further. And we did that. Yes, it was completely factored. We did that. No, not completely factored. The coefficient 0.5 is not an integer. And the last one, no, not completely factored. The polynomial could be factored further. Okay. All right. Now, the next subtopic is factoring out the highest or greatest common monomial factor. That's what we've already been doing, okay? The factoring process that we've discussed in this section, factoring out, if you have AB plus AC, factor out the common factor A, the greatest common factor, leaving B plus C, which have no common factors, often referred to as factoring out the highest common monomial factor. That's what we've been doing. The key idea in this process is to recognize the monomial factor that is common to all terms, and that's what y'all been doing very well, in fact. For example, what do we have here? What? 2x. Very good. That has a common factor of 2x. What's left over? Factor out the 2x. X squared plus 2x. Did I hear that? Plus 3. Very good. And insert within the parentheses the appropriate polynomial factor. Y'all said it. X squared plus 2x plus 3. Excellent. Okay? And they got it right too. Good for them. Okay? Now, how can you check and make sure you got your answer right? Go back and multiply exactly. Okay? Never a bad idea to do it. You got time to do it. The following examples further demonstrate this. What do we have here? 4x squared. There we have it. What's left? 3x plus 4. Excellent. How about here?
3x y cubed.
3xy cubed. Excellent. What's left over? 2x plus 9y. Excellent. Y'all are good. Really good. Okay. Let's do a few more. What you got here?
2b 4a minus 1. What you have?
Am I in the right class? Okay. What we got here?
9.
Okay. What's your greatest common factor?
2.
2.
2b.
Or not to be. Never mind. Okay. 2b. And what's left?
4a minus
4a minus 9. Okay. Got it. Okay.
9.
4y squared.
Plus 1.
And what you have? 2y plus 1 is what you said? Excellent. Okay. How about this one? Whoa! 6x cubed. There we have it. What's left over? 5 plus 7x. Right? Is that what you said? 7x minus 4x squared. Oh, they missed it, didn't they? That's supposed to be a minus sign. Shame on them. Okay. Y'all have to rewrite a book here, don't you? Okay. Okay. Let's see if they got it right in your text. Yeah, they got it right in the text. They just, whoever did the slide messed it up. Okay? Now, note that in each of those examples, the common monomial factor itself is not in completely factored form. This can be 2 times b. But guess what? A monomial is what we consider completely factored. This could be a 2 times y times y. Who cares? It's one monomial. Leave it in that monomial. This would be what? Yeah, 2 times 3 times x times x times x. Don't do it. Just leave it 6x cubed. Okay? So, no reason to completely factor a monomial. Leave it in the monomial form. The binomial, though, make sure it cannot be factored in further, or whatever you have left over. Make sense? All right. So let's do example 2. This time they didn't. I don't have to cover anything. Factor out the greatest common factor in each of the following. Okay? Let me get my pen. Wait, say again. All right. What you get? 3 x squared x squared plus, be sure you put the sign there, plus 5x minus 7. Okay, very good. Now, we're not at the point where we can do it yet, so they were kind to us and didn't have it. But later, we will always look at this and say, hey, can I factor that any further? As far as we go now, they're not going to sneak one past you here yet. But we'll always check this later. Say, can we factor that further? I'll tell you now, no you can't. Don't sweat it for now. Okay? Next. Say again. 2x. I heard someone say 2x. Is there 4? 2x. Why? Why not? Okay. And what do you have left? 4x squared. Y minus x cubed minus 6y. All right, good deal. Let's see how they did it. Okay? Everybody agree? Anyone have a disagreement with that? Okay, let's see. Each term of the first polynomial has a common factor of 3x squared. They saw that right. When they factored that out, that left them an x squared plus 5x minus 7. Take their word for it now, that can't be divided any further. Now this is going to lose what we got, so hang on to the concept here, okay? And the next one, the greatest common factor is 2xy. That's what we said. And what you have left is 4x squared y minus 3x minus 6y. Sure enough, they got it right. Any questions on that? Very good. All right. Now, unfortunately in the book, they skipped example 3. So let's go back and do example 3. Let's do it here. Okay, we got room. All right. 3x to the 4th plus 15x cubed minus 21x squared. Okay? Can that be factored? Say again? How? 3.
Hey, this was the first example.
Oh, that was the first example?
Yeah.
Oh, wait, I'm sorry. I'm copying the wrong one. Sorry. Y'all need to keep me straight here. Okay? Don't be getting confused. Okay. All right, the next one. I'm sorry. That's what the next subsection is. I missed seeing it. Sorry about that. Factoring out a common binomial factor. Okay? Now, you don't run into these this much, but they'll throw some in every now and then. Okay? Sometimes there may be a common binomial factor. Any kind of factor that's common to every term, whether it's monomial or binomial, factor it out. Here's an example. Here is an expression. Okay? Now, on one sense, this is a binomial expression. You got this expression plus that expression. Two expressions. But this expression itself is a monomial times a binomial, and this factor is a monomial times a binomial. But what do you notice about that? These two terms have a common factor of y plus 2. So factor that out, and what do you have left? What do you have left if you factor out y plus 2? X plus z, exactly. So then you would have, there it is down there, okay? So you would have x plus z, okay? So let's look, any questions on that? It's a little bit weirder, but they are common factors. They just happen to be binomials. You could even have trinomials. So let's do example 3, okay? Do you notice any common factors in the first one? B plus 1. So let's factor that out. B plus 1. And what do you have left? A squared plus 2. And guess what we always look to see? Can that second one be factored any further? I'll tell you now, no. Okay? Not going to be always, but for now, yeah, that one is a no. How about the next one? 2y minus 1 is a common factor. It happens to be a binomial, but it's a common factor. And what do you have left? X minus y. I think most of you can see that can't be factored any further, so we're done. How about the next one? X plus 2 is a common factor. And what's left? X plus 3. All right, good deal. Those were pretty easy, weren't they? Okay? Now, in real life, you won't run into those very often. May happen occasionally. But you could easily run into these. Oops, oh, they're going to do it for us. So let's see, did they get it right? Yes, b plus 1 times a squared plus 2, good for them. 2y minus 1 times x minus y, excellent. Okay, and x plus 2 times x plus 3, excellent. Okay, here is where you will run into it a bit more frequently. Factoring by grouping. Okay, what do we mean by that? It may be that the original polynomial exhibits no apparent common monomial or binomial factor, which is the case of this one. AB plus 3A plus BC plus 3C, no common factor. This has an A, that has an A, these two don't. This has a B, this doesn't, that does, but that doesn't. This has a 3, that doesn't, but that does. This has an A, but that does, but these two don't. So, no common factors, period. So what in the world could we do? Okay, now this technique works only on even number polynomials, even number term polynomials. 4, 6, 8, 10, 12, this will work only on it. If you have a trinomial, this will not work, okay? If it has a 5-term polynomial, it won't work. Only on even term polynomials. So what we do is group the terms. Okay? I'll do it down here. Okay? Now, in that first grouping, do you have any common terms? Common factors? A. And what do you have left? B plus 3. And in the second group, don't forget your sign there, okay? Second group, any common factors? C. What do you have left? B plus 3. And guess what? Now you have a common factor, B plus 3, so what can you do with that? Say again? If it's a common factor, factor it out. B plus 3 times A plus C. All right, so that one did have a factorization, but we have to do grouping to see if it works. Okay? And that's what they got to. We refer to that factoring process as factoring by grouping. Will all 4-term polynomials work that way? Bet you not. Okay? But sometimes you might have to do a little manipulation and investigation and try a few different things, but not all of them will work. But they're worth a try. So let's try these. What you reckon we can do with the first one? Well, first, group, not grope, okay? What do you have in the first one? Someone said it? B squared. What's left? A minus 4. Second group, plus 3 times A minus 4. And guess what that yields? A minus 4 times B squared plus 3. I'll tell you now that last one will not factor any further. Later we'll always check it to see if it does. It won't. Okay, how about this one? Group. In the first one, common factor of x, what do you have left? X. I can't hear you. Say again? Minus 1. You're factoring out an x from both of these terms. X out of here leaves you an x. X out of here leaves you a minus 1. Right? Distributing backwards. Okay? How about the second group? Don't forget your plus. 5 times x minus 1. And now what? Factor out the x minus 1. And what are you left with? X plus 5. Very good. All right. Now this next one takes a little more care. You know, there's always going to be a little complication somewhere here. What do you do first? Group. But this time, if that's a plus in between, forget about the plus. If it's a minus, you have to include the minus in the group. But this doesn't mean multiplying anymore. That's just grouping symbols, not multiplication. Here it's clear, they're just grouping. Here this is grouping 2. Don't think of this as a multiplication. It's not. In the first group, what do we have? X times, well, let me write on the line above, because they'll probably use this line below. Okay. Sorry. This will be what? X times X plus 2 minus 3 times X plus 2. Very good. Remember, that's why I said these minus signs, don't they always try to trip you up? There's just little things there and you fall over them lots of times. Okay, watch for your minus signs. When you factor out the minus 3, which you're doing, you factor out here leaving a plus x, but when you factor out a minus 3 out of that, minus out of minus leaves you a plus, 3 will go to 6. Watch them. Because minus signs love to sneak in there and mess you up. What can you do now? Okay, factor out x plus 2, and what are you left with? X minus 3. Very good. Y'all are good. Let's see how the book did them. Okay, the first one, they didn't show the grouping, shame on them, but they grouped them, and you got b squared times a minus 4 plus 3 times a minus 4. Good for them. And then the common factor was a minus 4 times b squared plus 3. The next one we're going to have to go on a new slide here, but we factored out x out of the first 2, left us x minus 1, factor out a plus 5 from the next 2, left us x minus 1. Now the common factor was x minus 1, leaving an x plus 5. Very good. And finally, on this one, we factored out an x from the first 2, get rid of x plus 2, factoring out the minus 3. Be sure you take the minus sign out, leaving you an x plus 2. If you're uncertain about it, go back and check it. Minus 3 times x is minus 3x. Minus 3 times 2 is minus 6. So yeah, that was done correctly. Now you have a common factor of x plus 2. Factor that out, and you got x plus 2 times x minus 3. Good deal, folks. I'm afraid we're going to have to stop there, aren't we? Okay. Now wait, before you start heading out the door here, we did example 4. Let me see. All right. We're going to start next time with example 5. Okay? Now, homework exercises, folks. For those who have books, if you don't have a book, want to take a picture of mine, take a picture of a neighbor's. Mine has answers in it, and I know you don't want to see those, okay? But do any of the odd numbers, either 1 or 3, and then do any of the odd numbers, 5 through 41. There's a whole passel, maybe a passel and a half of them, okay? Then do any of the odds, 43 through 63. Now, if some of those get a little confusing or bothersome there, hang on. We'll cover some more of those in class in examples. Oh, this is on page 150 and the top of 151. Okay, any of the, either 1 or 3 or both, and then any of the odds 5 through 41, and any of the odds 43 through 63.
What page is it?
That's page 150 or 151, and top of 151. Okay, and again, you don't have to do it. Say again.
What do you mean by any of the odds?
Okay, do a few, and if those get real easy, jump down a few and do a few more. Get to the point where you can't do them, or you can do them all, and then you're through. Okay, so they usually do the easiest one first, and then they go a little bit harder. So do some of all those. Do enough to convince yourself you got it down. If it takes all of them, do them all, but most of the time it won't, I think. Oh, why do I give you only odds? Answers in the back of the book are odd, okay? So you can say, yeah. Yeah.
Say to be on anything inside the book.
Anything, what?
How you got the research paper? Tell me.
Okay. Say again.
How do you want the research paper?
How do I want it?
Yeah.
Okay.
Like what's related on?
You mean your topic or what? The topic. You pick a topic. It just has to do something to do with algebra.
So
Anything.
we pick a person.
You can pick a person.
A little bit about them.
Yeah.
And then their math, like.
What they did, yeah, how they contributed to
Okay,
it.
so can I turn mine in Wednesday?
You certainly can.
How long would you
I'd love
like
to
it?
see. What's that?
How long?
1 to 2 pages.
Is it okay just a little over?
Yeah, oh yeah, absolutely. No problem being over. Yeah.
I need more information about that essay.
What's that?
I need more information about that essay.
What would you like to know?
Do you have like a handout or something?
No, I did. Yeah, I mean, I went over it in class. It's not on Blackboard yet, but it will be hopefully by this afternoon.
Okay.
Okay, but yeah, if you go back and watch the YouTube, you'll see me talk about it all.
Okay.
Yeah.
I'm talking about the science.
What's that?
The science class.
Right.
They have tests Tuesday, right?
Yeah.
But the notes, I couldn't put up the PowerPoints.
Okay, I'm going to try to get them done today. Like I said, I took everything over to the Birmingham campus Friday. Got time to do none of it. I took them all home this weekend and got time to do a lot of it, but I couldn't get on Blackboard to put them there. So I hope to this afternoon, if Blackboard's up, I'll hope
Okay, because
that.
the test is going to come from the PowerPoints.
Well, the reading is the main thing. And then after that, the PowerPoints and the
Those questions.
yeah, and those questions and things like that. Those questions would be great to review the reading and the PowerPoint stuff.
Okay.
Yeah.
Okay.
Were we supposed to turn this in with our phone number and our email?
That's exactly. This is the one
Okay.
you prefer to.
Yes, sir.
Okay.
And then the topic.
Is
Mathematics.
the music.
Is that good?
Fantastic.
Okay.
Yeah. Are you a
All
music
right, I'm
major
gonna
or
get
just
started
like
on
it?
I just wanted to make sure that was good.
Yeah.
before I
Oh,
started
very
on it.
good.
Okay.
Are you a music major or you just like
No,
music?
sir. I just like it.
Yeah. Math is all over it.
Okay.
Yeah.
All right.
Fantastic.
Thank you.
Believe it or not, math's all over art too.
That's right.
Yeah.
I saw that one too, but I like music better.
Yes. Excellent.
All right. Thank you.
Uh-huh. What did I just do?